It's great to be here. What a wonderful couple days. So as Phil said, I teach for SANS, and I'm also a proud alumni of the SANS Technology Institute. So if you want to know a little bit more about that, catch me after this. And I'm also the owner of Lucid Truth Technologies. We're a digital forensics firm that's based in Traverse City, Michigan. So in yellow, these are the two courses that I teach for the cloud curriculum. Cloud Security Essentials and Public Cloud Security for AWS, Azure, and Google Cloud. Because after all, how can you forensicate what you don't know? And of course, we also have co-opted Forensics 509 into our cloud curriculum, not just the forensics curriculum. So as I said about designing this talk, I wanted to make it interesting to all levels of cloud experience, all the way from none to expert. So I'll be covering some basic AWS EC2 concepts that will enable me to talk about this differential file system analysis technique. But I think that this technique is applicable to pretty much everywhere, all clouds, anything that makes a snapshot, including VMware snapshots, and for that matter, anything that can make a point-in-time backup. So even if you don't work in the cloud, stay tuned because there's something in here for everybody. And then I'll wind up talking about how we can use these concepts for more automation. So first of all, when we talk about virtual machines, well, AWS, we kind of chide them because they always come up with strange names for things. So they call it their Elastic Compute Cloud, or EC2 for short. And when we talk about an EBS volume, for that, really just think about, well, that's a virtual hard drive. And then they have machine templates. And what Amazon will call the machine template is an Amazon machine image. Now, as an instructor, I will often call it AMI, but the cool kids will call it an AMI. So, and then we have our snapshots. So as Matthew was talking about in his talk that preceded mine, a snapshot really is a point-in-time backup, and snapshots are incremental, which is another cool feature. I do have a hyperlink for you here in my slide, the middle one here, which is are snapshots forensically valid? So if you're doing digital forensics using snapshots and volumes created from them, well, you better be able to validate that in case you were challenged in court. So that is another resource for you. And you can't do much work in the cloud and talk to people that are working in the cloud space without them talking about CICD pipelines. And I once had a student, this was years ago, say, this cloud class is talking way too much about DevOps. And yeah, you can do the cloud without DevOps. You just can't do it well or at scale. And what we like about the DevOps approach or the CI/CD pipeline is it's not just about push button deployment, it's about doing it the same way in a very repeatable manner, right? Eliminating the human error of deploying code in a way that is inconsistent. Now in an on-prem world, they used to call the hardened server images a gold image. And this was likely because of the color of the DVD that they would burn that image onto. Now in the cloud, security advanced organizations will use hardened images as well. And of course, it's a best practice to build these images using a CI/CD pipeline. Of course, remember that in AWS, they're calling these an AMI or an AMI. I used to work at a company called Illumina, and there's even some YouTube talks that I've given at other summits about how we did DevOps at Illumina. But there we had a dedicated team that would build these images as a service and then share them out with the other AWS accounts in the organization for them to consume. And they called the AWS account that baked these images, they called that their bakery account. And obviously this bakery account needs to have a very high degree of security, otherwise you're at risk of a supply chain attack. Nowadays, Amazon has EC2 Image Builder. We didn't use the service back then because it hadn't existed yet, but that is essentially a managed service a managed CICD pipeline, if you will, for building out these images. We bake these images daily, and we used version controlled infrastructure as code script to do that. The nice thing being version controlled is that as we came up with improvements to our hardened image, we could push those out to production in a very short manner because of things like auto scaling and load balancing that helped us do the rolling updates. We also quickly learned that we had to unshare the previous versions of the images, otherwise those would be used to launch the new virtual machines. And what we were trying to do with this is we wanted to have no critical or high vulnerabilities in our production environment after X days. So what we did was we managed the virtual machine life to X days. This way we were able to patch in place in our build process rather than patching in place. So some history about me and I took Forensics 508 as part of my master's program back in 2017. And for those of you that have taken that course, you know that's focused on Windows forensics. But it occurred to me that I could apply some of those concepts to Amazon Linux systems. And since I was working at Illumina, we used EC2 quite a bit. So that was kind of an area of fascination for me. And I took some of these principles from Forensics 508, along with the SANS Linux intrusion detection cheat sheet, which if you've not seen that, check that out. That's a great resource as well. There's a Windows one as well. And that was where I created this gold paper, Digital Forensic Analysis of Amazon Linux EC2 Instances. And at the time, this was one of the very few resources that existed for doing forensics in AWS. And I had heard from colleagues that this paper was being circulated through Amazon, which was quite flattering to me, of course. I then later went to do a 4-hour workshop at Vancouver B-Sides and created my website, forensicate.cloud, which updated this gold paper with more recent content. And as part of that, I was kind of fascinated with the SIFT workstation. I took the SIFT workstation OVA and published instructions on how to make that into an Amazon machine image. Nowadays, I would not do that anymore. Not that I don't think it's a bad idea to work with the SIFT workstation in the cloud, but that's not the cloudy way to do that. What we do in the cloud is we provision a system that has just the resources that we need to do the processing that we need to do. And as a result, you can get by with a much smaller virtual machine and so forth. So then later I did a talk on automating this. And what we did was we automated the provisioning of the SIFT virtual machine. And then we also installed Systems Manager onto it. And then we had the Systems Manager remote control the SIFT workstation virtual machine to do a bunch of processing. And we did that according to a queue. So we could use the simple queuing service within AWS to tell it which EBS volumes to process. So pretty neat idea, but I'm not the most amazing AWS architect, so it was rather clunky, but so now let me just fast forward a little bit to talk about the basic concept behind differential file system analysis. So essentially what we're doing is we're taking a snapshot of a host prior to when it's compromised, and we're going to make a reference volume from that. And by the way, if you didn't make a snapshot prior to the compromise, what you can do is you can launch a virtual machine from the same AMI and make a snapshot of it. Especially if your AMI has all the stuff that you needed to stand up that machine in production, right? You don't launch a virtual machine in production and then install a bunch of software on it. You put all that stuff you want on it as part of your CI/CD pipeline. So that should give you a very good reference volume. And then post-compromise, we're going to make a snapshot, make a volume of that, and attach it to the virtual machine as well. And I like to make another volume, which is a data volume, to collect the evidence other than putting it onto the file system that we're booting the virtual machine from. And then from there, what we can do is we can generate a hash database of both the reference volume and the evidence volume, and do that to determine, well, which files have been added, which files have been deleted, and which files have changed. So ran into a wrinkle, which the XFS file system. Originally, Amazon Linux used ext4, but then when they converted to Amazon Linux 2, they switched over to the XFS file system. And there's a lot of good reasons for doing that, as listed on this slide. But one of the things that, like I said, was the wrinkle is SleuthKit doesn't support XFS yet. So maybe they will. There's some tickets that are created in the Git repo asking for this. And I believe somebody may have even ported it, or forked it, I should say, so that there may actually be a version of SleuthKit out there that does support XFS. But all right, so we've got that data volume. Let's format it. And we're going to format it with to be an XFS file system. So that's good. And then we're going to make some mount points. And then the next thing that you run into is, since the evidence volume is a clone at a later point in time of the reference volume, they have the same UUID, which means you could only mount one or the other unless you change the UUID of the partitions you want to mount. So we're going to see this when we come to my demo part. And then we're going to mount the reference and evidence as read-only, and the data is read-write, of course. Now, to create the hash databases, we're going to use the find command to find all the files on the file system, and then just pipe that into MD5 sum. And that will give us a reference files.md5 hash database. And we're going to do the same thing for evidence. Then we're going to use hfind from the SleuthKit to generate the index. So that way we can do a quick binary search. And this is pretty slick. And Brian Carrier talks about this in one of his SleuthKit informers. So this is a pretty cool utility. The nice thing about hfind is it will work on any file system, because it's just indexing the hash set. And by the way, one of the original use cases for this hfind utility was to work with the National Software Reference Library. I love the idea of the National Software Reference Library, because what it can do is it can allow us to reduce all the known files out of the system that we're trying to forensicate. But setting that up, with your forensic tools can be a little bit of a pain in the butt. But the nice thing is, when you have a reference volume, you can eliminate even more of those known files, including the custom files that you created, say, as part of a custom development, a custom web app or something. So we can eliminate more of these files. So here's how we'll do the quick win analysis. If the hash exists in the reference hash set, but not in the evidence hash set, well, then we know that it was either deleted or that the hash for that particular file has changed. Similarly, if it exists in the evidence set, but not in the original reference hash set, we know that it is either new or the hash has changed. So once we've got those two hash sets, if you will, we can then extract out the relative file names in both sets. And then we can say, well, which file names exist in one or the other to determine what is new, what is deleted, and what is changed. And right here on the slide, I'm showing a little bit of a comparison. So we see that we've got 32 change files, 1 deleted, and 25, 29 new files. And I'm even calculating the reduction ratio. So now we're working with just 6% of the files that are on that evidence volume. So that's a pretty nice quick win. So at this point, let me fire off my demo, and I'll talk through that as we go. Okay, so remember, I'm using EC2 just because I like EC2, but we can use this technique with anything that can make a snapshot. So the first thing I needed to do was to create a role. And a role is how we give an EC2 virtual machine permission to do things in the AWS cloud. So I'm going to attach some permissions to this role. And the two permissions I'm going to attach, one is EC2 full. And by the way, I'll be the first to admit that this is over permissioning the role, but we're doing this, that's a demo, right? So we can dial these in later. And then the other one that I'm going to give it is the S3 full, just in case I want to create a bucket or write my evidence to this bucket. Oh, and by the way, Matthew pointed this out, that typically what you do is you'd share these volumes with another AWS account. You wouldn't be doing it in the same account that had the compromise. All right, next thing I need to do is switch over to the EC2 service where we're going to launch two virtual machines. So the first one is going to be the prod host, and this is the system that we're going to compromise. And it's going to be a T2 micro, which is part of the free tier. And I need to put it into or I got to give it my SSH key. And then next, I'm going to put it into a security group. You can think of a security group as a firewall, essentially, packet filtering firewall. And this particular SSH security group is just going to allow me to SSH into the virtual machine from just my laptop. Egress is totally unfiltered. So that's our prod host. The next thing we're going to do is we're going to create our defer host. So going back to the EC2 console, we're giving it the name. This one's going to be an Ubuntu virtual machine, just because. And I need to give it the SSH key that I'm going to use. And I'm going to put it in the same SSH security group. Now in a production DevOps situation, this would all be done via something like Terraform as an example, or CloudFormation. For this virtual machine, I need to give it that role. So we're giving it the EC2 responder role, because I'm going to be running CLI commands on this virtual machine. All right, so now our two virtual machines are created. The next thing I'm going to do is I'm going to label the volumes just for the purposes of this demo, because we're going to be creating additional volumes, and I don't want the volumes from our host to get mixed up with the volumes that we're going to be creating here via the command line interface. So there's my defer volume. By the way, the prod volume was the one that was created first in chronological order. All right, so the next thing that I wanted to do was just SSH into my prod host. So I got to go back and grab the SSH command. So I can do that by just clicking connect here. This is pretty convenient. So as long as I'm in the directory where my private key, my PEM file is, I can just paste this command. And yes, I do want to connect. That's the first time I connect, and now I'm in. And I could have done this as part of the first boot, but I wanted to have my host have at least one SSH login. All right, having created that file, I'm going to now exit out. And I'm next going to SSH into the defer host because I'm going to do some configuration again. So I try to do this such that anybody who wanted to would be able to follow this even without a lot of cloud experience, and things would make sense. So grabbing the command to SSH into my defer host. Yes, I do want to connect. And now I'm into my Ubuntu system. And then I'm just going to run a couple of commands to configure it. What am I installing? Well, I'm installing the sleuth kit, bin utils, and then also the AWS command line interface. And after a few moments of configuration, I'm done. All right, and then from here, what I'm going to do is I'm going to set a variable called prod volume. So these commands are what you might see in, say, an incident response playbook, and they're designed so that I can just copy and paste them using command line kung fu. And as we learned earlier today, you can copy any of these commands and drop them in either Bard or ChatGPT, and it will totally explain what that command is. All right, so the next thing I'm doing is I'm logging into my Differ host and I'm infecting it with some malware. So I've got my snapshot pre-compromise. Now I need to make a snapshot post-compromise. So having done that, I'm now going to make the volumes. So let's start by making the reference volume. And this will take a few minutes. That's why I say wait for it. I've edited this video for brevity. And then I'm going to make the evidence volume. And we're running these commands one at a time, but you can see how that even, crawl, walk, run in a walking fashion, we could have ran these all together as part of one script. All right, the next thing that I need to do is make my data volume. And so having created all three of my volumes, I need one more piece of information, and that is the instance ID. So I'm going to get the instance ID out of the instance metadata service. That's a service that runs on that virtual machine that tells the virtual machine information about its environment. So I've got the instance ID. Now I can start attaching volumes. So I'm going to do them in order. I'm going to attach the reference volume. And we'll get some output. So it even tells me where the mount point is. Next, I'm going to attach the evidence volume. And then lastly, the data volume. All right. Now, next, what we can do is we can run ls-blk-f. And when I do -f, it will show me the UUIDs of all the partitions on all of the volumes that are attached to the virtual machine. And we can see there that we've got some conflicting UUIDs. So we're going to have to fix this before we can mount it. Also note that volume D doesn't even have a UUID because we've not yet formatted it. So next I need to format it. And when I did, I found that I forgot to switch to root. So just rolling with it, right? You just roll with things, especially in the cloud. All right, so now I've got my drive formatted. It even told me what the new UUID is, but I'm gonna run ls-blk-f again to get my list. And I can see that now volume D has a UUID as well. I still need to fix the duplicate UUIDs on partition 1 of both my reference and evidence. So let's do that. Okay, and then when I run ls-blk, we can see that it is now fixed. Okay, now from this point, we can then create some mount points. And then we can mount our drives, or our partitions to be precise. Great. Now, the next thing we should do is, since we wanted them to be read-only, is let's test them. Let's test them using touch. So it should fail for evidence and reference, but not for the data. And voila, so we're good to go. And it's at this point that we can start doing our hashing, right? So I'm going to make a directory within the data volume to do the hashing. There's what the hash table will look like. And as I was working on this, I came with a strange issue where I had a strange character, a / in my or backslash in my before one of my MD5. So I'm just fixing that with sed. And I think that was just due to a strangely named file, but but we're rolling with it, right? Now, what I can do is use hfind to generate the index files. And I can see that I've got 2 new files that were created for each of the 2 hash sets. And from here, we can start doing our set operations, where what we can do is we can see what is unique. So here I'm creating I'm finding the hashes that are unique to each of the 2 hash sets. Cool. Now, after we do that, so now I know the hashes that are unique to each set. What I need to do is extract out or combine in the file names. So I'm using grep to do that. So it'll create the hash with the file name per line in the file. So I've got my new and changed and my missing and changed file names. And then from there, what I'm going to do is I'm going to figure out which file names are unique in each of the 2 lists and which ones are in common. And that will give me my changed files, my missing files, and my new files. Now let's see how many there are, right? I love word count. Word count -L counts the number of lines. And I even give you the command to determine the reduction ratio. The reason why there's so many new files there is because I put a lot of fun stuff. If you do follow my demo, you'll see all kinds of interesting indicators of compromise and malware samples. All right, so now that we've done that, we can start doing some real basic forensics. First of all, let's take a look at our list of new files. And that's just that important.txt. So that was deleted in our evidence. And now let's take a look at our changed files. And well, we see that cron tab is changed. So let's use the diff command to look at the difference between the cron tab in our reference volume and our evidence volume. Uh-oh, somebody scheduled something. That looks a little suspicious. Let's take a look at it. Now, when we take a look at it, though, remember that we got to use its current location, which would be in /mnt/evidence plus that particular file. So let's just use strings. That's a common first step, right? Oh, look at that. That looks like signs of malware persistence, doesn't it, on a Linux system? And the next thing is, well, let's go back and take a look at our change files again. And it looks like there's netstat. What's going on with that? Netstat really shouldn't have changed, right? Unless we did a bunch of system updates. So let's simply just list it out in the evidence partition as well as the reference partition. And we can see that netstat on evidence is quite a bit larger. And if you actually do this, you'll see that that has been Trojanized. So this is stuff that I've come across as part of my investigations. All right, and then one last one. Let's take a look at this. So we see we have a brand new one called, oh, and it's in grub, right? Nothing suspicious about something that doesn't belong in grub. So we can simply just cat it out. Yep, I'm just running new again. Yeah, let's cat it out and yep, oh, bin hello. What's going on there? So again, this is one thing that I will often forget. I got to put in the path to the evidence partition before I then take a look at the file I want to look at. And there we go. We see some script that's trying to create some beaconing to go back home. Oh, one last thing. We've noticed that there was this AWS credentials file, and this is a big problem, right? So somebody hard-coded credentials just prior to the compromise. So that's my little demo for you. And then before I wrap up, what I wanted to do is just talk briefly about a slide that we've seen today. But this slide is the automated forensic orchestrator for EC2. And just to put things into context, why do we like to do things like forensic orchestration? It's the same reason why developers and production operators like to use that CICD pipeline, right? Because then we can do things at scale and we can do it in that same repeatable way. So again, shout out to Jonathan Pauling, who is one of several contributors on this particular project that not only does file system forensics, but it will also take a snapshot of the memory as well, or an image of the memory. So one of the things that this is focused on is creating a forensic timeline, right? Because a forensic timeline will also show you some of the changes that have happened to that system's file system. But remember, we can use this differential file system technique on any cloud, anywhere we have backups. We just need to create a volume pre and post compromise. So pretty simple concept. And you're probably saying, well, no duh, Ken, but I wanted to throw that out there because it's so simple. Why not do it, right? It's kind of like file integrity monitoring, but after the fact. Okay, so that's what I have for you. Any questions, thoughts, or comments?
Hey, so I noticed you were changing the GUID or the UIDs on the disk image so that it wouldn't be a conflict when mounting. I've never actually done that, but what I have done, and maybe there's a reason for doing it your way with changing them, you can pass a no UUID option with the mount command, and it'll basically, ignore it and mount it anyway. So I didn't know if there was a reason to actually do the physical change, or
no, your way would probably be even better, right? Because then we're not altering anything. So yeah, good point.
Okay, thank you.
Yeah.
Do you know why Etsy Shadow and Etsy Password were listed as new files in the new file list?
Yeah, so I chose to use the compare command later. I'm not sure if it was in the recording because if you look, there's /Etsy password and there's a /Etsy password with a hyphen following it. So in a previous iteration of this, when I was using grep to do the comparison or to find the new file system, because the Etsy password was found in Etsy password dash, it threw it off. So then if you repeat my work in the version that maybe wasn't recorded, I fix it by using the compare, where it's doing an exact line by line comparison. So yep. Very good catch. I'm impressed you saw that. Okay.